So, you're into machine learning, right? Then you know it's all about the data. But how does a machine actually go from just a pile of raw numbers to real, actual intelligence? Well, it all starts with a few foundational ideas from statistics. Today, we're going to break down the three core concepts that let machines find meaning in a world of data.
All right, let's really think about this for a second. When we look at a spreadsheet, we can see a story, right? A story about sales or weather or, well, anything. But for an algorithm, it's just a big old wall of numbers. No context, no meaning. So how in the world does it start to make sense of all that chaos?
Well, it has to learn a language. And no, not a human one, but the language of statistics. This language is really built on three fundamental ideas that give those numbers context, some structure, and ultimately the power to predict. Okay, so the very first idea is all about finding the center point, what we call the mean. Before a model can do anything fancy, it has to figure out a baseline. It needs one single number that represents what's normal or typical in all that data. Now, you probably know the mean as just the average, simple enough. But for a machine learning model, you should think of it as the data's center of gravity. It's the most basic prediction you can possibly make. If you had to guess a value with zero other information, the mean is your safest bet, statistically speaking. It's ground zero for a machine's understanding. So why is this so crucial for a machine? Well, beyond just finding the middle, the mean is absolutely essential for normalizing features. This is huge because it stops a feature with massive numbers, like say home prices, from totally drowning out a feature with small numbers, like the number of bedrooms. It puts everything on a level playing field, and that's the anchor point for pretty much any analysis. Let's make this super simple with an example. We've got 5 students here, and these are their test scores: 60, 70, 80, 90, and a perfect 100. So how can we describe how this entire group performed with just one number?
By finding the mean, of course. And in this case, it's 80. That one number, 80, tells the model, hey, the typical performance here is a B-. It becomes our central reference point, our baseline that every other score is measured against. But okay, knowing the middle of the road isn't the whole story, right? So let's move on to our second key idea. We also have to understand how spread out the data is, and that brings us to variance. This tells us if our data is all bunched up and predictable, or if it's, all over the place. So variance is basically just a number that tells you how much the data points scatter around that mean we just talked about. Are they all clustered together, suggesting a really consistent pattern, or are they all over the map? Variance puts a number on that level of consistency, or total chaos. And this is where it gets really interesting, because variance basically tells a model how confident it should be. If you've got high variance, that's a red flag for unstable, noisy data. And that's when you get overfitting, right? Where the model starts learning all the random noise instead of the actual pattern. But low variance, that suggests consistency, which makes it way easier for a model to learn reliable patterns without getting distracted. Okay, to really hammer this home, just imagine 2 different classes that both have the exact same average test score of 75. Just looking at the mean, you'd shrug and say, yeah, they're pretty much the same. But oh no, variance is about to tell us a very different story. And this slide just lays it all out. Check out Class A. The scores are all clumped together, 74, 75, 75, you get it. Super consistent, super low variance. A model could confidently predict a new student will score around 75. Then you have Class B. Same average, but the scores are all over the map, 50, 100. A machine has to put a number on that difference in reliability, and that's exactly what variance is for. All right, so we've got our center point with the mean, and we understand the spread with variance. What's next? The final piece of the puzzle is all about finding those hidden relationships between different data points. And that brings us to correlation. Simply put, correlation just measures how 2 things move together. It answers a really simple question. Hey, when this variable goes up, what does that other one do? It's like being a detective. You're looking for partners in crime within the data, spotting patterns and relationships. And this is what makes a model way smarter and more efficient. By understanding which features are related, a model can do something called feature selection, basically focusing on what's important and tossing out the stuff that's redundant. And this is critical because, believe it or not, some models get really confused if you feed them 2 columns that are basically saying the same thing twice. Correlation helps clean all that up. This table lays it out perfectly. First up, positive correlation. Both things go up together. Think, the more hours you study, the better your exam score. Makes sense, right? Then you've got negative correlation. One goes up, the other goes down. Like when the temperature rises, your heater usage plummets. And of course, no correlation. There's just no connection. Your shoe size has absolutely nothing to do with your IQ. Okay, so we've looked at these three ideas one by one: mean, variance, correlation. But the real magic, the aha moment, is when you see how they all work together. This is when a machine starts building a truly structured picture of the data. It's all about building a complete picture. First, mean comes in and says, okay, this is what's normal. Next, variance chimes in with, and this is how much things tend to change around that normal. And finally, correlation points out, oh, and by the way, these things are connected: center, spread, and relationship. Think about our recommendation engine on your favorite streaming service. The mean helps it figure out the average rating for a movie. Variance tells it if everyone feels the same way about that movie or if the opinions are all over the place. Is it a divisive cult classic? But correlation, that's the secret sauce. It finds other people who rate movies like you do, and then it connects the dots to suggest something new you're probably going to love. These three simple stats are guiding every single suggestion you see. All right, as we start to wrap this up, I want you to remember one thing. You don't have to be a math whiz here. Right now, what's most important is building that gut feeling, that intuition for what these concepts mean. I love how the source material puts this. It says these tools aren't really about complicated math formulas. They are about clarity, structure, and insight. They're the tools that let a machine find the signal in the noise to bring some kind of order to that chaos of raw data. So, I'll leave you with this question. You now know the absolute basics, the vocabulary that machines use to interpret the world. You can speak the language. So, now that you can, what would you ask your data? What secrets are you going to go looking for?